Hi, this is Mr. Ward, and today's Do Now 21.1 is a preview of some quadrilateral proof concepts from 5.5 and 5.6. And even if you haven't gotten there, though, you've got plenty of tools that you can incorporate with some of these basic ideas. So there's some basic properties of a parallelogram that you'll need for number one. For one thing, there's a definition. The opposite sides are parallel by definition. That is what makes a parallelogram a parallelogram. And then there's related theorems, which are things that you could prove. The opposite sides are congruent. The opposite angles are congruent. So this angle and this angle are congruent, this angle and this angle are congruent. The diagonals bisect each other. That means that AC is split in two equal pieces by DB and vice versa. DB is also bisected by AC. Any pair of consecutive angles are supplementary. So this angle and this angle are supplementary to each other. This angle and this angle are supplementary. This angle and this angle are supplementary. And this angle and this one are supplementary. So you'll need at least one of those things here. So down here for number one, you want to have read the properties of parallelograms above. You want to incorporate one of them into the tools you already have to prove this. Now, here's a Captain Obvious note. The symbol right next to RTBX, this symbol right here, that looks like a parallelogram. Wait for it, this is really mind-blowing. It means that RTBX is a parallelogram. That's what it means. Okay, so we know that RTBX is a parallelogram, and we know that RS and WB are congruent. And we're trying to prove that XT bisects SW. So XT bisects SW. So to do that, to prove that, it would be useful to be able to prove that SK and WK are congruent. If we want to prove that, it would help a lot to be able to prove that SKT and WKX are congruent, because then you could Kappa-Kadika that and demonstrate that this and this side were congruent, and therefore XT bisects SW. Well, let's see if we have some information that'll help us. So first, we've got our givens. Okay, and we'll go ahead and label some things we know. We know this and this are congruent. And we're trying to prove that this and this are congruent. So it would certainly help. Well, let's think about some things we can figure out. So since it's a parallelogram, XB and RT are parallel. So XB is parallel to RT by definition of a parallelogram. Okay, opposite sides are going to be parallel. Now, you also know that XR is parallel to BT. Same. Okay. Now, that gives us some really useful information about these two triangles. So we can definitely demonstrate that KST and KWX are congruent because they're alternate interior angles. So we can say angle KST, angle KST is congruent to angle KWX by pairs of alternate interior angles. Postulate. Okay, so alternate interior angles are congruent. Okay, and that's because XB and RT are parallel. So let's label that. I'll pick a different color. So we know that KST and KWX are congruent. So that's really useful. Now, what about this angle here and this angle here? Well, it turns out they're also congruent. KTS, because, KTS, so angle KTS is congruent to angle KXW, and it's the same reason as before, the pairs of alternate interior angles postulate. Okay, so because XT is a transversal for these two parallel lines, then KTS and KXW are alternate interior angles. So let's pick a different color for that. We'll use light blue. We're almost there. We've almost got a couple of congruent triangles that will help us prove that KS and KW are congruent. So let's see what else we can say. Well, we can say that ST is congruent to WX, and here's why. RT, actually, let's see. We do need to state this. We need to say RT and XB are congruent. Okay, RT is congruent to XB by definition of, let's go back up there and take a look. So opposite sides of a parallelogram are congruent. So that's actually not a definition, it's a theorem. So we're going to say because opposite sides of a parallelogram are congruent. Now, once we've established that, we're in pretty good shape. So what we've just established is this is congruent to this. And we know that this and this are congruent, so we can now prove that ST and WX are congruent. We can do that by subtraction. So ST is congruent to WX by subtraction. And once we have that, we actually can prove those two triangles are congruent. So I'm going to do this. This and this are congruent. So now we can say that SKT and WKX are congruent by angle side angle. So triangle SKT is congruent to triangle WKX by angle side angle postulate. Okay, now that we've got that, we can say that SK and WK, SK is congruent to WK by kappa Kataka. Corresponding parts of congruent triangles are congruent. Okay, now that we have that, we can say that XT bisects SW by definition of a bisector, because we just proved that these two sides here, I'm going to go with this red, KS and KW are congruent by kappa Kataka. We're bisecting it, so it breaks it into two congruent parts. Now let's take a look at the next one. So for the next one, again, and let's remind ourselves what we use. We use the opposite sides are congruent. Okay, now we're going to look at the next one. We're going to be using, these are all the properties of parallelograms in reverse being used to prove that a quadrilateral is a parallelogram. This is 5.6 stuff. And so we're going to need this. So if both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. That's a reverse of the definition of a parallelogram. If both pairs of opposite sides of the quadrilateral are congruent, then the quadrilateral is a parallelogram. If two sides of the quadrilateral are both parallel and congruent, then it's a parallelogram too. And if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And then finally, this one is apparently fairly hard to prove, but will be needed in Chapter 7. if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so let's see what we're dealing with. We've got this circle O, and we are just given it's a circle O, which means O is in the center. Conclusion, SMPR is a parallelogram. Well, let's think about what it means that it is the diagonals intersect at O. What that means is that OS and OP are congruent because they're radii. It also means that those are congruent to that OM and OR are congruent because they're also radii. And that means that SP and MR are bisecting each other. So after the givens, then we can say SO is congruent to PO by radii of circle are congruent. And then that's theorem 18, I believe. And then we can say that MO is congruent to RO by same. And then we can say that MR bisects SP by definition of a bisector. Okay. Now, once we've demonstrated that these diagonals, so these are the diagonals, I'm just going to make a note, diagonal, MR bisects diagonal SP by definition of a bisector because it splits, they each get split into congruent parts that happen to be radii that are all congruent. Okay, so once we've demonstrated that, then we can go back up here and take a look at the options. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So we can now just say SMPR is a parallelogram because the diagonals bisect each other. All right, I hope that was helpful, and I will stop now.